Welcome students, in this part of video we will discuss how to draw ray diagrams related to concave and convex mirror showing the formation of images, and we'll place objects at different position and we'll try to draw the diagram so that we can get the images at different positions. उन डायग्राम्स को समझने के लिए, रे डायग्राम्स को समझने के लिए first we should know the types of spherical mirror and what is spherical mirror. Now if I ask you what is a spherical mirror is a part of a hollow sphere made up of glass polished from one side. So I'm considering this tennis ball, this is a sphere and a sphere का outline will be a circle. I'm considering this as the hollow sphere made up of glass and I have divided into these two parts. It is hollow inside. So the hollow sphere made up of glass. So ये ग्लास का स्फेयर और हम इस ग्लास का स्फेयर को दो पार्ट इक्वल पार्ट में डिवाइड करते हैं. ये सेंटर and I can easily divide this into two parts. If I polish one part from outer side using shiny metal or alloy, then reflection of light will take place from inner surface, or we can say concave surface, or we can say bent in surface. And the other part if I polish it from inside, दूसरा पार्ट को मैंने पॉलिश किया है अंदर की तरफ से, then the reflection of light takes place from outer side. So if I ask you what is a spherical mirror, spherical mirrors are those mirrors which are the part of a hollow sphere made up of glass and polished from one side. There are two types of spherical mirror. One is called concave mirror and the other one is convex mirror. Now which is concave mirror? Concave mirror is a type of spherical mirror which is polished from outer side and in which reflection of light takes place from inner surface, or we can say bent in surface or concave surface. Convex mirror is a type of spherical mirror which is polished from inner surface in which reflection of light takes place from bulging out surface, or we can say convex surface. So this one is concave mirror and this one is convex mirror. Okay, and this diagram represents both types of spherical mirror. So now if I ask you the three terms, spherical mirror, concave mirror and convex mirror. So what do you mean by the term spherical mirrors? Spherical mirrors are those mirrors which are the part of a hollow sphere made up of glass and polished from one side. Concave mirror is a type of spherical mirror in which reflection takes place from bent in surface or concave surface and which is polished from outer surface. Convex mirror is a type of spherical mirror which is polished from bent in surface and in which reflection of light takes place from outer surface, or we can say bulging out surface. So concave mirror is also called converging mirror, is also called converging mirror, and convex mirror is also called diverging mirror. So these are the two types of spherical mirror that we discussed, concave and convex mirror. Now we'll discuss terms related to spherical mirrors. We'll discuss the terms like center of curvature, pole, radius of curvature, principal axis, principal focus, and focal length. So the first term that we are going to discuss is center of curvature. Now what is center of curvature? The center of the sphere of which spherical mirror is a part. ये spherical mirrors जिस स्फेयर का पार्ट है उसी का सेंटर को हम लोग बोलेंगे सेंटर ऑफ कर्वेचर, डिनोटेड बाय लेटर C. So the center of the sphere of which spherical mirror is a part is called center of curvature. Now this is the reflecting surface, and center point of the reflecting surface of spherical mirror is called the pole of the spherical mirror. So we have discussed two terms. First one center of curvature, second one pole. Now what is pole? The center of the reflecting surface of spherical mirror is called the pole of the spherical mirror. Our next term is radius of curvature. अगर मैं C और P को join करता हूँ, I will get what? Radius, because this is center, the point on the outline. So this is the radius, and the CP represents radius of curvature that can be denoted by letter R. So if I join C and P, that CP represents radius of curvature. It represents radius of curvature. So I discussed three terms: center of curvature, center of the sphere of which spherical mirror is a part; pole, the center point of the reflecting surface is called the pole of the spherical mirror; radius of curvature, the radius of the sphere of which spherical mirror is a part. Now principal axis. Principal axis is a straight line joining the 2 points, center of curvature and pole, and it is extended on both the sides. We can say that straight line passing through center of curvature and pole is called principal axis, that can be denoted by symbol XY. Now what is principal focus? Try to understand. If I allow a parallel beam of light parallel to the principal axis, parallel beam of light parallel to the principal axis to fall on concave mirror. In case of concave mirror, this parallel beam of light after reflection will always pass through a point on the principal axis. Will always pass through a point on the principal axis. Each ray of light after reflection passes through that point. And this point on the principal axis is principal focus. This point is principal focus. And principal focus of concave mirror is real because light rays actually intersect here. And for this reason only, concave mirror is also called converging mirror. Is also called what? Converging mirror. Okay, so if I ask you focus of which mirror is real, focus of concave mirror is real. Now if I allow a parallel beam of light to fall on convex mirror, if we allow a parallel beam of light to fall on convex mirror, after reflection, these light rays will appear to diverge from a point on the principal axis. These light rays appear to diverge from a point on the principal axis, and this point is principal focus. And principal focus of convex mirror is virtual because light rays do not actually intersect here. And if you look at this diagram, after reflection the light rays appear to diverge from a point on the principal axis, and thereby convex mirror is also called diverging mirror, क्योंकि लाइट रेज रिफ्लेक्शन के बाद किसी एक पॉइंट से डाइवर्ज हो रहा है और यहाँ पे लाइट रेज रिफ्लेक्शन के बाद किसी एक पॉइंट पे कन्वर्ज यानी मीट हो रहा है. सो कॉन्केव मिरर इज ऑल्सो कॉल्ड कन्वर्जिंग मिरर, convex mirror is also called diverging mirror. So we discussed the terms like first one, center of curvature, pole, radius of curvature, principal axis, principal focus. Now if I ask you what is the definition of principal focus? Principal focus is a point on the principal axis of a concave mirror at which the light rays incident parallel to the principal axis converge after reflection, and principal focus of a convex mirror is a point on the principal axis from which the light rays incident parallel to the principal axis appear to diverge. And principal focus of concave mirror is real, principal focus of convex mirror is virtual. And the last term here, focal length, the length of the line joining the focus and pole, that is FP. FP represents focal length. If I ask you CP represents what? CP represents radius of curvature. XY represents what? XY represents principal axis. P represents what? P is the pole of the spherical mirror. F is the principal focus of the spherical mirror, and C is the center of curvature of the spherical mirror. If you have understood these terms, then you can easily understand the rules for drawing ray diagrams as well as the ray diagrams to show the formation of images. I request all the students to draw all these diagrams properly using scale, pencil, compass, eraser. These things are very much required. You should practice it properly, otherwise you will find it very difficult to draw these diagrams properly during examination. Now we'll discuss rules or rays for formation of images by concave mirror. First we'll discuss rules and then we will discuss the proper ray diagrams showing the formation of images. Now the four important rules for concave mirror. This is concave mirror, and if I allow a ray of light incident parallel to the principal axis, if I allow a ray of light incident parallel to the principal axis in case of concave mirror, now what happens to this light ray? This light ray after reflection passes through principal focus. This is the rule. So if a ray of light incident parallel to the principal axis in case of concave mirror after reflection, it will always pass through focus. Now if a ray of light incident after passing through focus, if a ray of light incident after passing through focus, then what will happen to this light ray? This light ray after reflection will become parallel to the principal axis. Will become parallel to the principal axis. Now, third rule, if a ray of light incident after passing through center of curvature on the mirror, if a ray of light incident after passing through center of curvature on mirror, the ray of light incident normally, that means this angle will be 90 degree, and if a ray of light incident normally, it retraces its path, it will reflect along the path of incidence. Another rule we can use, if a ray of light incident at pole, this ray of light incident obliquely, and here principal axis behaves as normal because principal axis makes an angle 90 degree to the mirror. So this ray of light incident obliquely, and here principal axis behaves like normal. So after reflection, what will happen to this light ray? This will reflect symmetrically. This will reflect in such a way that this angle, that is angle of incidence, is equal to this one, angle of reflection, following the laws of reflection. So we discussed 4 important rules for formation of images by concave mirror. First one, if a ray of light incident parallel to the principal axis in case of concave mirror, after reflection, the ray of light passes through focus. Second one, if a ray of light incident after passing through focus on concave mirror, after reflection, this light ray will become parallel to the principal axis. Third one, if a ray of light incident after passing through center of curvature, this ray of light incident normally, it retraces its path. And the fourth one, if a ray of light incident at pole, it will reflect symmetrically such that principal axis behaves as normal and the angle of incidence is equal to the angle of reflection. So these are the 4 rules for formation of images by concave mirror. For concave mirror, we will draw 6 different diagrams, and for 6 different positions of object. In some cases, we will draw 2 diagrams for each position. So if you are ready with such a diagram, then you will be able to draw the diagrams quickly. I suggest you, in some pages, you should draw this part, and then one by one with this video, you can draw all the diagrams quickly. Now I'll discuss our first ray diagram. First one is for concave mirror where object is placed at infinity. So position of object is at infinity. We will discuss the formation of image for concave mirror drawing the ray diagram. So in the first one, object is placed at infinity, but I am considering in the first case incident rays are parallel to the principal axis, and in the second case incident rays are not parallel to the principal axis. So in both the cases object is placed at infinity. So for this diagram we can consider 2 light rays parallel to the principal axis, one above the principal axis and another below the principal axis for convenience, and object is placed at infinity. Since the object is at infinite distance, it is shown like this. We can draw dotted lines to represent the rays coming from that object. These rays fall on the mirror, concave mirror, and we know the rule: if the light rays incident parallel to the principal axis, after reflection, this light ray will pass through focus. This one, after reflection, will also pass through focus. So here we can see that image is formed at focus. Now for the second one, the incident rays are not parallel to the principal axis, but they may be parallel to each other or one another. So for convenience, I am considering like this: one ray incident after passing through focus, the other one incident and is parallel to the principal axis, so we know that if a ray of light incident after passing through focus, it becomes parallel to the principal axis. It becomes parallel to the principal axis, and for the formation of an image, minimum 2 rays are required, because image is a point where 2 or more light rays converge, or is a point from where 2 or more light rays appear to diverge after reflection or refraction. So image formation के लिए minimum required number of rays is 2. So first one I have drawn, and the second one I am drawing. this light ray incident at pole, and after reflection it intersects the reflected ray, this one, at this point. You can see that I have already marked this point for convenience, so that I can pass this light ray through this point, so that intersection actually or exactly takes place at this point. So from this point I can draw an image. So the image is formed at focus. We can mark focus properly. Yes, F represents focus, and image is formed at focus. So if you look at these diagrams, if you find it difficult, this second one, you can draw first one, and both are important. So here, incident rays are parallel to the principal axis. After reflection, light rays converge at focus. Here, incident rays are parallel to one another, but they are not parallel to the principal axis. After reflection, the light rays converge at a point, and here also image is formed at focus. So if you look at the diagram, if I ask you what is the position of image, we can write at focus, at principal focus. Nature of image: real and inverted. Why real and inverted? Because the light rays actually intersect at that point. And size of image is point like, or we can say highly diminished. Point like or highly diminished. So we discussed the first ray diagram for concave mirror. In total we will discuss 6 different points, and the first point where position of object is at infinity. If object is placed at infinity, image is formed at focus. The second diagram, second one, the ray diagram showing the formation of image by concave mirror if object is placed beyond center of curvature or between infinity and center of curvature. So position of object is beyond C or between infinity and C. This time we can draw an object in front of the mirror like this, and from the top of the object a ray of light incident parallel to the principal axis. A ray of light incident parallel to the principal axis. We know what will happen to this light ray after reflection. After reflection, this light ray passes through focus. And again from the top of the object, a ray of light incident after passing through focus. And we know the rule, what will happen to this light ray. This light ray will become parallel to the principal axis. After reflection, the two reflected light rays intersect at this point. Here we can draw an image like this, perpendicular on the principal axis. If AB is the object, we can consider A dash, B dash as the image. So if object is placed beyond C, the image is formed between C and F. We'll draw this diagram in another way by using different rules. Object is placed beyond center of curvature. You know that if object is placed beyond center of curvature, image is formed between C and F. We are considering a ray of light incident parallel to the principal axis. We know that after reflection, this light ray will pass through focus. If I consider a ray of light incident after passing through center of curvature. We know the rule, this light ray incident normally and will retrace its path. So we are getting image between C and F. Image between C and F. So if AB is the object, A dash, B dash is the image. So if I ask you, you can draw any one of these diagrams which you feel convenient for you. Position of image is between C and F. C is the center of curvature, F is the focus. The nature of image is real and inverted upside down. And why real? Because light rays actually intersect after reflection, and size of the image is smaller or diminished. So in this way we can draw ray diagram for this position, that is position of object beyond C, and position of image we are getting between C and F. Nature of image real and inverted, size of the image smaller or diminished. Now I'll discuss third point, where object is placed at center of curvature. This diagram is not a simple diagram to draw, because here the image is formed at center of curvature when object is placed at center of curvature, and it is difficult to get that image exactly at center of curvature. I will show you. If I get it in the first attempt, that will be my good luck. This is the mirror, concave mirror, and this point we can mark. This is center of curvature. Measurement is important here. And this principal axis, and this is pole. The length of the line joining C and P is radius of curvature, and I considered this gap to be 5 centimeter for convenience. Okay, and the mirror has to be polished. Now an object is placed at center of curvature. I am taking it as 1.5 centimeter, and we know that if object is placed at center of curvature, image is also formed at center of curvature. So for convenience you can do one thing. You can mark the position of image here. So I have considered this as 1.5. So at around 3 centimeter mark, I am marking a point, and I will try so that reflected light rays should intersect at this point. So a ray of light incident parallel to the principal axis. If a ray of light incident parallel to the principal axis, the ray of light passes through focus. For convenience, I am not marking focus at first, but we know that it should be the midpoint. And after reflection, this light ray passes through focus and should touch this point. And if you can mark this point, it will be convenient for you. If a ray of light incident after passing through focus, and if it is your good luck, then it will touch this point. And we know the rule, if a ray of light incident after passing through focus, in case of concave mirror, after reflection it becomes parallel to the principal axis, and the two reflected light rays exactly meet at the point where we wanted, and image is formed at center of curvature. You can see here, if object is placed, AB is placed at center of curvature, image is also formed at center of curvature. Object can be represented as AB, image A dash, B dash. In this particular diagram, some measurements are very important. I considered between C and P, it is 5 centimeter, and object size 1.5 centimeter. You can also draw for other measurement, that depends on you. Here, if I ask you what is the position of image, position of image is at center of curvature. If I ask you what is the nature of image, nature of image is real and inverted, as you can see in the diagram. And size of image, size of image is equal to the size of object. I suggest you to practice this diagram 3-4 times, because I know that it is very difficult to get the image exactly at center of curvature in this particular diagram. Object is placed between C and F. So here we can mark this point. This is pole, this is center of curvature, and I consider this as 5 centimeter around. So 2.5 centimeter is the principal focus. So this point is the focus, and this is center of curvature. This is pole. Now the object is placed between C and F. This time, if you take smaller object, it will be convenient for you to draw the diagram. So I'm considering this as 1.5 centimeter. Here it is given between C and F, तो C और F के बीच में कहीं भी आप ऑब्जेक्ट प्लेस कर सकते हो. A ray of light incident parallel to the principal axis. In case of concave mirror, after reflection, this light ray will pass through focus. This light ray is passing through focus. थोड़ा एक्सटेंड कर देते हैं. And a ray of light incident after passing through focus, according to the rule, this light ray will become parallel to the principal axis. And the image is formed beyond center of curvature. You can see here, if AB is the object, A dash, B dash is the image. Now I'm drawing another way. The same diagram can be drawn in another way, where object is placed between C and F. This time I'm considering around 1 centimeter. Object is placed between C and F, and a ray of light incident parallel to the principal axis. If a ray of light incident parallel to the principal axis, after reflection, we know that this light ray passes through focus. This light ray passes through focus. Now if I consider a ray of light, this has to be extended. If I consider a ray of light incident on the mirror, normal incidence, we know that any line that joins C and the mirror is normal or perpendicular to the mirror. So I am touching this point of the scale to the center of curvature. So a ray of light incident normally after reflection passes through center of curvature. Okay, so this light ray incident normally retraces its path. So after reflection, these two light rays meet here. At this point, we can draw the image. We have to make a slight extension here, and this is the position of the image. So if object is placed between C and F, image is formed beyond center of curvature. AB is the object and A dash B dash is the image. Okay, so if I ask you in this particular diagram, position of image, position of image is beyond center of curvature, or you can write between infinity and center of curvature. If I ask you what is the nature of image, nature of image is real and inverted. What about the size of image? Size of image is enlarged or magnified, we can say. Enlarged or magnified. So what we have discussed, if object is placed between C and F, image is formed beyond C, or we can say between infinity and center of curvature. Nature of image is real and inverted. Size of image is enlarged or magnified. In this part, we'll discuss point number 5. Object is placed at focus or principal focus, and we are discussing ray diagrams for concave mirrors showing the formation of images. This particular diagram can be drawn in two ways, so whichever you feel convenient, you can draw that. I am showing you two different methods. Object is placed at focus. So I am placing the object at focus. If object is placed at focus, we can consider a ray of light incident parallel to the principal axis. A ray of light incident parallel to the principal axis. If ray of light incident parallel to the principal axis, after refraction, we know that this light ray passes through focus, and we can draw another ray incident at pole, and it reflects symmetrically, and it will reflect in such a way that the reflected light ray is parallel to the previous reflected light ray. So these two reflected light rays, they are parallel, and it is said that image is formed at infinity. So if object is placed at focus, image is formed at infinity. Nature of image will be real and inverted, and size of the image will be highly enlarged or magnified, we can say. There is another way of drawing the same diagram where object is placed at focus, a ray of light incident parallel to the principal axis. If a ray of light incident parallel to the principal axis, after reflection, this light ray passes through focus, and another ray of light, it incident on the mirror in such a way that there is normal incidence, and this light ray will retrace its path. after reflection, and the reflected light rays, these two light rays should appear parallel to the principal axis. So this one, first one, a bit convenient, and second one, there is normal incidence. You have to take care that the light ray should touch these 2 points. So if object is placed at focus or principal focus, position of image is at infinity. Nature of image is real and inverted. And about the size of image, it is enlarged or magnified, we can say. Enlarged or magnified. So हम लोगों ने डिस्कस किया पॉइंट नंबर 5, जहाँ पे ऑब्जेक्ट is placed at focus in case of concave mirror, and if object is placed at focus, image is formed at infinity. Nature of image real and inverted, and size of the image is enlarged or magnified. In this part we will discuss 6th point, where object is placed between focus and pole, and this is the last diagram for concave mirror, but we will draw this diagram in 2 different ways. This is the first method, where object is placed between focus and pole. We can consider a smaller object between focus and pole, and a ray of light incident parallel to the principal axis. A ray of light incident parallel to the principal axis. After reflection, we know that this light ray passes through focus, and I am considering another light ray incident normally. And normal incidence, we know that after reflection will pass through center of curvature. So I am touching these 2 points with the scale. A ray of light incident normally. This light ray after reflection retraces the path and passes through center of curvature. It retraces the path and passes through center of curvature. So these 2 light rays are diverging in nature. If we produce these 2 light rays back, they will meet at a point. So I am doing what? I am producing these 2 light rays back. The first one and the second one. When I produce these 2 light rays back, the 2 light rays appear to diverge from this point, and here we can draw a perpendicular in dotted line. This will represent the image. So if AB is the object, A dash B dash is representing the image. So if you look at this diagram, if I ask you what is the position of image, we can write behind the mirror. The nature of image is virtual and erect. Now what about the size of image? Size of the image is highly magnified. Size of the image is highly magnified. So if object is placed between focus and pole, the image is formed behind the mirror. The image is virtual and erect. Why virtual? Because light rays do not intersect actually here. Size of the image is highly magnified or enlarged, we can say. But we can also draw the same diagram in another way. The 6th one, where we know the position of object. Object is placed between F and P. So we can draw the mirror using the compass. This is concave mirror, and we can mark the center of curvature. This point is the center of curvature. So this is the polish on the mirror. This is now concave mirror because it is polished from outside, and the center point is the pole. We can draw the principal axis. By drawing principal axis, you should keep in mind that the backside portion of the mirror will be required for the formation of image. This point is the pole, and the midpoint between C and P is around 2.5. This is focus, and according to question, where is the object placed? Object is placed between focus and pole, anywhere in between focus and pole. It is not required that exactly at midpoint. So object is placed between focus and pole, and we know that if a ray of light incident parallel to the principal axis, if a ray of light incident parallel to the principal axis, then after reflection, we know that this light ray passes through focus. After reflection, this light ray passes through focus, and this time we'll consider a ray of light incident at pole. And if a ray of light incident at pole, we know that this angle and angle of reflection, they are equal. So you will see that after reflection, the two reflected light rays should appear divergent in nature. If we produce this reflected ray back, and this one, if we produce this light rays back, we'll see that the two light rays appear to diverge from a point, this particular point, and here we can draw the image. So if AB is the object, A dash, B dash is the image. With this diagram, you can see clearly that image is highly magnified. So if I ask you what is the position of image, we know the position of image behind the mirror. If I ask you what is the nature of image, nature of image is virtual and erect. Then what about the size of image? Size of image is highly magnified. Compared to the object, it is highly magnified. So this is one of the most important diagram, because out of the 6 diagrams, all 5 formed real and inverted image, and the 6th one, for the position between focus and pole, we get virtual image which is highly magnified. And this is very important property of concave mirror. Because of this property, concave mirrors are used as makeup mirror, okay, shaving mirror, because if you place your face between focus and pole, highly magnified image of the face can be seen, and that will help in doing shaving easily and in makeup also. For drawing ray diagram related to convex mirror, we should consider some measurement. The distance between the pointer and the pencil, as we considered in concave mirror, you should take it as 5 centimeter, and then you can draw the mirror, the outline of the mirror. So you can mark this point. This point is center of curvature. Don't forget to polish the mirror from inside, because convex mirrors are polished from inside. This is center of curvature, we have already marked. And then you draw the principal axis. So this point is pole, XY is the principal axis, and the midpoint between P and C is 5, so 2.5 centimeter. At this point we can mark principal focus. So if you are ready with such diagrams, then it will be easier to draw the diagrams, ray diagrams, quickly. For convex mirror, we will draw around 4 diagrams, 2 for one position and 2 for other position. First we will draw for infinity, object is placed at infinity, and second we will draw for object placed anywhere in front of concave mirror. For that also we'll draw 2 diagrams. So if you follow this measurement and you are ready with such diagrams, so along with the video you can draw these diagrams quickly. Now in this part we will discuss rules or rays for the formation of images by convex mirror, and we will discuss 4 important rules. And the first one, if I consider a ray of light incident parallel to the principal axis. Parallel to the principal axis in case of convex mirror. We know that focus and center of curvature in case of convex mirror, they are behind the mirror. So if a ray of light incident parallel to the principal axis, after reflection, this light ray appear to diverge from focus. You should draw like this. First you draw the dotted line from focus. This light ray appears to diverge from focus. And the second one, opposite of the first one, if a ray of light appears to converge at focus, ये light ray किधर आ रहा है? Towards focus. So we know that it cannot reach focus, it appears to converge at focus. So after reflection, this light ray, will appear, or this light ray after reflection will become parallel to the principal axis. So first rule, a ray of light incident parallel to the principal axis after reflection appears to diverge from focus. And second one, opposite of the first one, if a ray of light appears to converge at focus, it becomes parallel to the principal axis. Now the third one, if a ray of light appears to converge at center of curvature. It appears to converge at center of curvature. There will be normal incidence here. With mirror it will be 90 degree and the ray of light retraces its path. And the fourth one, if a ray of light incident at pole, it reflects symmetrically. Symmetrical reflection where principal axis behaves like normal. तो ये लाइन नॉर्मल के जैसे बिहेव करेगा. And this is the reflected light ray. These two angles should be equal, angle of incidence and angle of reflection, and we can extend it back. That will help us in formation of images. So 4 important rules for convex mirror. First one, a ray of light incident parallel to the principal axis appears to diverge from focus. A ray of light which appears to converge at focus becomes parallel to the principal axis. A ray of light which appears to converge at center of curvature retraces its path. A ray of light which incident at pole, it reflects symmetrically. So these are 4 important rules for drawing the ray diagrams related to the formation of images by convex mirror. Now we'll discuss ray diagrams showing the formation of image by convex mirror. In the first one, where object is placed at infinity. 2 ways of drawing this diagram, whichever you feel convenient, you can draw that. Object is placed at infinity. In the first one, I am considering the object is at infinity, so we can consider the incident light rays parallel to the principal axis. इंसिडेंट लाइट रेज पैरेलल टू द प्रिंसिपल एक्सिस। अगर इंसिडेंट लाइट रे पैरेलल टू द प्रिंसिपल एक्सिस है तो यहाँ मार्किंग हम लोग करना होगा, दिस इज पोल एंड फोकस सेंटर ऑफ curvature with measurement. You will have to do the marking. And these light rays, after reflection, these light rays appear to diverge from focus according to the rule. These light rays appear to diverge from focus, principal focus. So if you look at this diagram, if object is placed at infinity, the image is formed at focus, and if you want, you can draw an image at infinite distance, and from that object we are considering the rays like this. Okay. And in the second diagram, the incident light rays are not parallel to the principal axis, but they are parallel to one another. So here pole, focus, center of curvature. This time the light rays are parallel to one another but not parallel to the principal axis. So in this case also, image should be formed at focus. So I am considering two light rays, one towards C, towards center of curvature. If a ray of light incident, normally it retraces its path, we know that. So this light ray, it appears to diverge from center of curvature. Another light ray I am considering, which is parallel to the principal axis, I'm considering another light ray which is parallel to the previous incident ray, and which appears to converge at focus. This light ray appears to converge at focus. So after reflection according to the rule, this light ray, after reflection becomes parallel to the principal axis. If you produce it back, it will intersect with this reflected ray. So this is the point of intersection, and here we can draw the image. So if object is placed at infinity, image is formed at focus. The first one is convenient, but the second one is for another pattern. First one, here incident light rays are parallel to the principal axis. Second one, incident light rays are not parallel to the principal axis, but in both the cases object is placed at infinity. So if I ask you the position of image at focus, nature of image is virtual and erect. And what about the size of image? Size of image is point-like, or we can say highly diminished. Point-like or highly diminished. So first diagram for convex mirror, object is placed at infinity, image is formed at focus, nature of the image virtually erect, size of the image point-like or highly diminished. Now in this video we will discuss ray diagram for convex mirror when object is placed in front of the mirror at any position. We have already discussed about first point, that is object is placed at infinity. Now object will be placed anywhere in between infinity and pole. I will show you two different diagrams, but whichever you feel convenient, you should draw that. So object is placed in front of the mirror. If object is placed in front of the mirror, we can consider a ray of light incident parallel to the principal axis. If a ray of light incident parallel to the principal axis, after reflection this light ray appears to diverge from focus. This light ray appears to diverge from focus, and if a ray of light appears to converge at center of curvature, it appears to converge at center of curvature, this light ray retraces its path. So it appears that the two reflected rays are diverging from this point, this one as well as this one. So we'll get a virtual and erect image of the object between P and F. You should draw a dotted line for virtual image, and this is the image. So AB is the object. We can mark A dash, B dash as the image. Now another method of drawing this particular diagram. Object is placed in front of the mirror. A ray of light incident parallel to the principal axis. After reflection, this light ray appears to diverge from focus. This light ray appears to diverge from focus. And we can consider another ray which incident at pole. It reflects symmetrically. So these two angles should be equal. And if we produce this reflected ray back, it intersects at this point. So this reflected ray, they appear to diverge from this point. So this is the image of this particular point A. Let this be A dash. So we can draw image from here. This is B dash if we mark this as B. So if object is placed in front of the mirror, image is formed behind the mirror. The size of the image is smaller compared to the size of object. So now the position of image if you write, it is behind the mirror, more properly between focus and pole. Now nature of image is virtual and erect. Now what about the size of image? Size of the image is smaller or diminished. So in this way you can draw the ray diagram for convex mirror. The 2 diagrams are there for convex and 6 diagram for concave mirror. And about concave mirror, you have seen that both real and virtual images are formed, and magnified as well as diminished images are formed. But in case of convex mirror, a convex mirror always forms virtual, erect and diminished image of the object placed in front of it. Whatever is the position of the object, it always produces virtual, erect and diminished image of the object placed in front of it. Now it's time to announce the name of the top 5 winners of the last challenge question that I gave in Chapter Light Part 2. The winners are number 1 Somaditya Dev, number 2 Parth Sharma, number 3 Debarth Chakraborty, number 4 Sarthak Patni, and number 5 Prashant Mishra. I received about 100 entries, and they are the top 5 who gave the correct answers.